Okay, some more example problems for 3F. So let's go into some more complex stuff that you'll be doing in a short time. So this first one here, a to the power of 3 to the power of 4. Now, if you remember correctly, I think it's index law 3, states that if there's an index number raised to another power, you times those two. Okay, so a 3 to the power of 4 is actually e 3 times 4. Okay, that's a to the power of 12. Okay, that's as far as you can go with this one. Now, this one's a little bit more difficult. We've got 2 times y5 all to the power of 3. Now, remember, when this is a combination of our the product rule and the, what was the other one? The power rule. Okay, so because this is all in brackets, this 3 applies to both the 2 and the y5. Okay, so what it's going to give us is 2 to the power of 3 and y 5 times 3. Okay, so 5 times 3, just like we did in the one before. Okay, so simplifying this, 2 to the power of 3 is 8. Y, 5 times 3 is y 15. Okay, so now a bit more of a step here. There's quite a big jump up here. We've got a fraction, so it's our quotient rule, our power rule, and our product rule all together. Okay, so what this is telling us is this fraction in the bracket is all raised to the power of 3. So every number gets raised to the power of 3 in this question. So let's write it out again, and we'll apply a power of 3 to each one. Okay, so 3, the first one is 3 to the power of 3. Now x2 times 3. Okay, because we've got to multiply those powers together. Okay, on the bottom line, we have 5 to the power of 3. So 5 to the power of 3, y2 to the power of 3, and z to the power of 3. Okay, so notice when there is a power already there, I have to multiply that power of 3. Okay, so 3 to the power of 3 is 3 times 3 is 9, 9 times 3 is 27, and x2 times 3 is x6. Okay, so on your denominator, 5 to the power of 3. Now, just keep in mind you're not timesing it. 5 to the power of 3 is not 15. 5 to the power of 3 is 5 times 5 times 5, which is actually 125. Okay, y2 times 3 is y6, and z to the power of 3 is z3. Okay, so I think that's it. I'm trying to think. You may be able to divide these. I don't think so. If you could simplify these coefficients, you should do it as well, but I don't think you can. Okay, and finally, I've got this d, which is a bit of a doozy. Combination of about 4 different laws. Okay, so as I said in the previous video, it doesn't actually matter which laws you apply in what order. If you do it correctly, it should work. But having said that, the first thing I would do would be to get rid of brackets. Okay, so if you don't know where to start, remove brackets. I think is probably the best strategy. Okay, so often you have a look at these things and there's x's and y's and numbers everywhere, and if you don't know what to do, get rid of the brackets. Okay, it's going to take you a few steps to do these ones. Don't try to do everything at once. Just in general, try to apply one rule at a time and simplify one step, one rule. Okay, so the first thing I'm going to do is get rid of this bracket here. Okay, so these things have been raised to the power of 3. Okay, so this 3 applies to the x and it applies to the y squared here. So I'm going to have 3. Now it's going to be x3. Now y2 times 3 is y6. If you remember, we multiply the powers in this case. Okay, so times, everything else stays the same, and 8x squared y. Okay, so that was my power rule, and now I'm going to use my I'm going to do my first index law, so the multiplication rule, and I'm going to simplify the top line. Okay, so on the top line, okay, I'm going to do my coefficients first. 12. Now x3 times x4 is actually x7. If you remember, we add 3 plus 4 to get x7, and y6 times y2 is y8. okay, as 6 plus 2 is 8. Okay, divided by, again, I'm going to just keep it like that. And now it comes down to a division question. So I've got my division rule. Okay, so I'll just write up here what I've done in each one. So this is index law 1. So that's the yep, and I'm going to do index rule 2 here, index law 2. Okay, to simplify this one now. 12 divided by 8 can be simplified. They both divide by 4. Okay, so 12 divided by 4 is 3, and 8 divided by 4 is 2. Okay, so my last line, I'm going to have 3 over 2. Now, x7 divided by x2, if you remember with our index law 2, when you're dividing index numbers with the same base, you take away the power. So it's going to be x5. Okay, 7 take away 2 is x5. y8 divided by y, okay, if you remember y is going to be 1. Sorry. 8 take away 1 is 7. So it's going to be y7. All right, and that's as simple as it gets. You'd probably, oops, hang on. Yep, so this is pretty much done. It may be written like this in the answers. Okay, so that's that one there. Finally, where did I add some more here? Are these ones with the 0 power? Okay, so these can be a little bit tricky because of the way some of them are written. So if we have a look at this one here, let's do this one first. 4a to the power of 0. Now, it might be tempting to just say, well, that's to the power of 0. Well, that's just 1, isn't it? Okay, but what you have to realize is only the a has been raised to the power of 0. 4 is actually 4 to the power of 1. So what we're looking at here is 4 to the power of 1 times a to the power of 0. Okay, so we know 4 to the power of 1 is 4, and a to the power of 0 is 1. So we're going to actually get 1 times 4, which is 4. Okay, don't let that confuse you. Now, the second one here, let's take a look at this. You've got two different things happening here. So 2p to the power of 0. Now we know that's going to be 2 times 1. Okay, so that's going to be 2. All right, now this one's a little tricky. It's in brackets, and it's in brackets for a reason. They're quite different because what that's saying is 3p, whatever 3p is, that is all raised to the power of 0. Okay, so anything raised to the power of 0 is going to equal 1. So this whole expression here, or this term, is going to equal 1. Okay, because anything to the power of 0 is equal to 1. So it's actually going to be 2 plus 1. So the answer to this one is 3. Okay, so careful with brackets. It probably they can trick you sometimes. All right, so have a go at some of the questions, and don't forget to like and subscribe.